This is a brief introduction to motion diagrams. So, we've already learned about representing motion on dot diagrams. Motion diagrams take dot diagrams one step further. First, we start with the same concept as a dot diagram. Then, we're going to add an arrow to represent the object's velocity at each moment in time. So you'll see here that we have dots representing equal time intervals where the object is. All we've done is add arrows in between the dots which represent the velocity of the object at each moment in time. Therefore, just like on a dot diagram, the dots are closer together when the object moves slower. The velocity arrows are shorter when the object moves slower. For a fast-moving object, the dots are going to be far apart, and the velocity arrows are going to be longer. If the object changes velocity, the arrows representing the object's motion will change in length. This object is speeding up, so the velocity arrows get longer as the object moves. But we're not done yet. We can't just leave it with velocity arrows. We have to add something which tells us how the velocity is changing from one moment to the next. So, we always start with a dot diagram, add velocity arrows, and then we add something called a change in velocity arrow. Your motion diagram is not complete without this. The way we figure out how to draw a change in velocity arrow is we look at the first two velocity arrows and determine how they are different. This second arrow is longer than the first. Therefore, the object must have been speeding up. So we can say that the velocity arrow changed by stretching to the right. So when we go to add our velocity change arrow, we will add an arrow pointed to the right. This arrow will be labeled with delta V for velocity change arrow. This shows us now not just which direction the object is moving, given by the velocity arrows, but also in which direction the change in velocity is occurring. If the object is getting slower, then the velocity arrow changed by getting shorter. We can say that this is almost as if the arrow got squished back towards the left. So which direction is the change in velocity for this object? It's back towards the left. So you'll notice when the object is slowing down, the change in velocity arrow is directed in the opposite direction of the velocity arrows. So how about for this one? We see the object is moving to the left and slowing down. If we apply the same rule that we saw with the previous ones, then if the object is speeding up, the change in velocity is in the same direction as the motion. If the object is slowing down, the change in velocity is opposite the object's motion. Therefore, in this case, the change in velocity arrow points back towards the right.